Good morning, everyone. My name is Murat Gunerdi. I'm steel manager at Colakoglu Metalurji, which is located in Turkey. The stainless steel market in Turkey has been increasing year by year. According to our tap management request, we studied the possibility of stainless steel production in our existing plant. It was a big challenge for us because our plant is designed for carbon steel. We have searched a lot, but we couldn't find any company that can produce stainless steel and the carbon steel at the same time. And then we evaluate with prime metals. Together we investigated our processes and equipments. After some modernization projects, Mr. Chetin will explain to you details, we succeeded to produce 304L stainless steel grade in 2020. I would like to briefly introduce my company. Colakoglu is one of the diversified conglomerates in Turkey involved in steel production, shipping, energy, information systems, mining, foreign trade, and finance. Today, the group employs 12,000 people. Colakoglu is involved in the iron and steel business, began with the steel trade, started in 1945. In the course of time, with several investments in melt shop and hot rolling process, today Colakoglu has become one of the biggest steel producers in Turkey. Our melt shop capacity is 3 million tons per year. Our hot rolled coil production capacity is 4.5 million tons per year, and rebar production capacity is 1 million tons per year. This is the route of stainless steel making: electric arc furnace, ladle furnace, deslagging unit, vacuum oxygen, decarbonization plant, and continuous testing machine. According to market demand and our sales department recommendation, we decided to produce 304L stainless steel grade. This is the aim analysis of 304L. The chromium content is between 18 to 18.3. The nickel content is 8 to 8.2. And the carbon is the most critical element in this grade because it's hard to keep the carbon level below 300 ppm with such amount of alloy additions. That's why we decided to make an investment for VD to VOD revamp. We have a huge furnace with 300-ton tapping weight and 9 RCB burners in the furnace, but we didn't use them to avoid chromium oxidation. So the cold spot possibility was occurred. The first step, we put the scrap into the furnace with 3 baskets instead of 2. And Primet has created a new melting model to prevent cold spots. We had to be sure that there was not any unmelted scrap in the furnace. The other crucial difference was charging the 80% of alloying additions were done in electric arc furnace instead of ladle furnace. Approximately between 380 to 400 kWh per ton, total energy was consumed. And when the temperature rises above 1710 degrees, the energy was cut off and liquid steel tapped to the ladle. We have a EBT furnace, which is normally a disadvantage to take all slag from furnace to ladle. But at the same time, we have a big tapping hole, which is 350 mm, so we didn't have any clogging or tapping problem. And the ladle transferred to the ladle furnace. We use aluminum and ferrous silicon for deoxidation, calcium aluminate, lime, and fluorspar for slag optimization. The main aim of the ladle furnace process is deoxidation, desulfurization, alloying, and temperature adjustment. And this is the final analysis of 304L. After the LF process, all slag on the top of the ladle was skimmed in the slagging station to prevent sulfur pickup and also effective oxygen blowing in VOD process. Then the ladle came into the VOD plant. Sampling, temperature, and free bot measurement were carried out before the cover was closed. When the vacuum pressure was decreased to 200 millibar, oxygen blowing starts automatically according to level 2 model. There were 2 crucial parameters on the carbon removal kinetics. The first one is the distance between the top of the lens and the liquid still surface. The other one is argon flow rate. Oxygen blowing amount is determined by model depending on chemical analysis. Blowing was terminated by the model when the carbon monoxide and carbon dioxide ratio reached below 1 to avoid chromium oxidation. This is the carbon monoxide line, and this blue one is the carbon dioxide line. This is the intersection point, and just after the intersection point, as you can see, the oxygen blowing was stopped. After oxygen blowing phase, the vacuum pressure down to below 2 millibar. In this point, natural decarbonization is occurred with reaction of free carbon and dissolved oxygen. It called vacuum carbon deoxidation, VCD phase. The carbon aim after the VCD phase is below 60 ppm. During the 304L stainless steel production in 2022, we achieved 5 ppm carbon level, which was the lowest one after VCD phase. And you may see the final analysis range. The oxidation was done by the addition of styrosilicon for chromium reduction at the end of the VCD process. After lime and fluorspar addition, in order to adjust the select viscosity, then the cover opened. Ferrosilicon, low carbon ferromanganese, and all the other alloy elements were added according to required analysis. Also, cooling scrap was added to reach aiming temperature. The ladle was transferred to the CCM process. And as you can see, I think it is the classical problem for all VOD plants. The steel shell is typically composed of splashing under the roof during oxygen blowing. In our case, its thickness was about 30 millimeters. In the beginning, we tried to cut it by oxygen lens, but it was taking too long. And then we designed a special equipment to remove it. In the CCM process, the aim temperature was 1490 to 95 degrees at the tannish. It means that the aim of spare heat temperature was 35 to 40 degrees. We used magnesium oxide tannish bonder instead of silicium oxide based. Mold taper, oscillation pattern, cooling practice, and other casting parameters were optimized for stainless steel. Casting speed was between 1.0 to 1.2 meter per minute in order to casting conditions and maintained consistently. And the slabs were cut using an iron powder implemented torch cutting machine. My part is finished. Thank you.
I'm from Nanyang Special Steel from China. Thank you for your excellent presentation. I have one question. How do you control the carbon pickup after the VOD process? Thank you.
Okay, thank you very much. It's a very important point, of course. We use magnesium carbon bricks in the ladle. And we use also the same one for stainless steel, but with low carbon content. As I remember, it was 2% instead of 14%. And in the process, the carbon pickup is related with the steel temperature. So after the VCD process, when we measured the temperature, we immediately calculated the required cooling scrap, and we put into the ladle as fast as possible. On the caster side, we used magnesium oxide based tannish powder instead of silicium oxide based. And for mold powder, we prefer which has lowest melting point and lower carbon content, of course. And for isostatic refractory, we used special design for carbon steel. Thank you.
So, second question. Thank you very much. I have a question related to your presentation. I think the process that you developed is based on the vacuum pump solution. And I would understand if you, in terms of even the carbonization, because we have many technology that you can produce the the steam for vacuum production through the waste heat. If in terms of pollutant removal in the steel and overall, let me say, environmental friendly process, this could be even a solution, or you prefer to use the vacuum pump because it is for metallurgical reason?
Actually, we had VD plant, so we revamped to VOD plant. So we have very limited place for another technology. So actually, we had to use VOD.
Okay. So many questions.
Thank you for the presentation. I want to ask you that what kind of equipment did you use to remove the steel shell at VOD process?
And this is also for you.
Okay, thank you. Actually, I should draw actually, but I'll try to. Yeah, I'll try to explain it. It is like an octopus and with 8 arms, and there is a stopper here, so the arms cannot fall down. And we fix them together, and we use plastic rope. It is very important. And in the middle of the arms, there is a lifting point. We put into the steel shell this equipment by crane, and when it goes up, the plastic rope was burned, and the arm was open. So when we lift up, it came with steel shell. It is simple but very helpful equipment.
Hello, thank you for your presentation. I am Musa from Vesuvius. I have a question for your refractory consumption. Is there any significant change with your refractory consumption during this application?
This is my bit. Okay, of course, in stainless steel project production, the tapping temperature is higher than the carbon steel, and the lifetime of the electric arc furnace bricks will be less. It's for sure. But we didn't have any unexpected situation, or we didn't face any abnormal wearing on the bricks, electric arc.
Thank you.